Okay, let's look at the exercise of 2.2a first. Okay. Question number 2, because number 1 I've already discussed with you all in the previous lesson. So look at number 2. Given that matrix P is equal to, this is the one, and then you're given the matrix Q, matrix R, calculate P minus Q plus R. So P is 12, 1, negative 3, 4, minus Q is at negative 2, 0, 5, you copy down, plus R is 6, 3, 7, negative 1. So you do the calculation, 12 minus 8 plus 6. You have this, 1 minus negative 2 plus 3. So you have this, solve everything, so you will get 10, 6, 4, negative 2. Check your answer. Whereas for question B, they want you to find out P plus Q minus R. So you copy down everything, P plus Q minus R. Solve it, 12 plus 8 minus 6, and so on. You do for the rest. So the answer is 14, negative 4, negative 10, 10. This one. Okay, I proceed with question number 4. Yasmin cannot join because internet connection is slow. Okay. Now, number 4 here. Given that 3a plus 2 and 9 minus b plus 4 to b equal to 15, negative 8, calculate the values of a and b. So this one you can straight away take out the row, the first row and the first column, the element in it, 3a plus 2 plus 4 equal to 15, solving the equation over here. So 3a is 15 minus 2 minus 4, a equal to 9 over 3, so a equal to 3. Whereas for b, same thing, 9 minus b plus 2b equal to negative 8. So this is the one. Solve it to find the variable. So the answer will be negative 17. Check, huh? Okay, then we move to question number 5. Given that you have given matrix S, matrix T, and S minus T equal to this. Calculate the value of X, Y, Z. So you can see your X are here, your Y are here. This is your X and your Z. So find out. We are going to find out one by one first. So you get the equation from the given statement here. S minus T equal to 10, negative 11, negative 2, negative Z. And then you are going to substitute the S into this, minus T into this, equal to what is given over here. So you copy down. Okay, and then you got to solve it until you get an equal matrix. Equal matrix. So 4x plus 1 minus x equal to 10. You jot down one by one 4 of the elements in here and equate it. Therefore, 4x plus 1 minus x equal to 10. So you solve it over here. 3x, 4x minus x equal to 3x. So 10 minus 1 equal to 9. Therefore, your x is equal to 3. Okay, and then for the y, 6y, I take this, 6 minus y minus 7 equal to negative 2. So negative y is equal to negative 2 plus 7 minus 6. Either one, up to you which one comes first. So negative y is negative 1. Then we have to change it to a positive variable here, y equal to 1. Okay, next. We have to find the z. So you refer back to your question here. Which one we have z? This one. Therefore, you are going to equate this element here, x minus y equal to z. And then we've already found out the y just now, the y equal to 1. So you substitute the y here, which is equal to 1. Therefore, it is 3 minus 3 times 1 equal to z. So z equal to 0, like this. Okay, then we proceed to question number 6. You're given here the two matrices, the addition of two matrices minus V equal to 11, -4, -1, 5, 6, 9. So calculate V. Okay, so I move these two to the back here. Therefore, the remaining will be negative V, which means the answer minus this, minus this. So I got to minus 2 of it. Okay, we got to make it becomes an equal matrices. So here 11 minus 3 minus -7 for each of the element. Okay, you solve everything, all the elements in here, you write down, calculate it, and you will get 15, -2, -11, -1, 2, -6. Then because it is negative V, we have to change it to a positive number. So it's just the normal multiplication. The whole thing you multiply by a negative sign. So negative, negative, you get a positive V. Negative times this matrix over here, you get a negative matrix. After that, you are going to multiply the negative into each of the element. So it will be -15, 2, 11, 1, -2, 6. That's the answer. Okay. Continue. Question number 7. So this is about the income and expenses of Mr. Gopal. He has two stores, store A and store B. Okay, and then he sell the food and drink. This is the income. And then the other table is showing the expenses for the store A and store B, the food, the expenses for the food, and also the expenses for the drink. They ask you to calculate the total profit, given that the formula of profit is equal to income minus expenses. Okay, so we are going to write down the four of these into the form of matrices. Okay, this is 2650. Because they just want to get the profit right, so I add both the food and drink together. Therefore, it will be 2650 plus 1890. Same for the store B, 1560 plus 910. And then when I spend money, so I minus, follow the given formula. So therefore, food plus drink, 930 plus 850 here, 540 plus 260 here. Therefore, the calculation will be like this. Okay, and you get the answer. 4540 minus 1780 becomes 2760. The other one is 1670. That is the profit for this question. Okay, because they ask you to show your calculation in the form of matrices. Therefore, no matter how, you have to show this way. If they didn't state this question, then you are going to show it the normal way, whereby you are going to add up everything over here, and then you just minus everything over here. Okay? So, I think that's all for this exercise. Let me see, correct or not. Up to question number 6, 7. Yes, correct. Any question, class?
No questions, madam.
Question. Okay, let me see how many of you right now. 25 only, so little. Okay, never mind. We are going to proceed straight away to multiply a matrix by a number. Okay, let's see this one. How to multiply a matrix by a number. This part is easy. You don't have to worry. It's just like you multiply a number of what do you call it? A variable or a term. For example, x. 5 multiply 5x is 5x. That's all. So I'm going to skip this part. Sorry. I'm going to skip this part very fast. So here, look at the yellow box. This one. It is given that matrix A, B, C, D, and N is a number. So hence, N times A is equal to N multiplied by the matrix just now. It becomes N times A, N times B, N times C, N times D, like this. Okay, and N is known as a scalar. Okay, or scalar, sorry. So multiplication of matrix by a number is known as a scalar multiplication. Remember this. Okay, so I continue with example 11. If you look at example 11 here, this part I'm just going to explain very fast because I think you can get, you can understand this part very fast. So example 11, given that D is equal to this, Okay, calculate 3D. 3D means you are going to use 3 multiplied by the matrix given. So 3 times -5, you get a -15. You got to show all this first, huh? So 3 times 4, 3 times 2, 3 times 1, each of it. 3 times 4, 12, 3 times 2, 6, 3 times 1, 3. Okay, that's how you get your answer. And then when it comes to -1/2 times d, it will be -1/2 times 5, -5, 4, 2, 1 with this one. Okay, so -1/2 times -5 is a positive 5/2. This -1/2 times 4 is a -2. If you know, it becomes -4/2, right? Cancel it, you get a -2. -1/2 times 2 is a -1. Okay, and then -1/2 times 1, it remains the same, -1/2. Simple, huh? Okay, we continue with the next question. This one is about the mind mobilization to find out the commutative law, distributive law. The one that you have learned in Form 1, commutative law is A plus B equal to B plus A, the normal one. Distributive law means that, for example, A times B plus C, it is equal to AB plus AC. That is distributive law. And then for associative law is A plus B plus C equal to A plus B plus C in bracket. And the last one is the identity law. Identity law is the one that involves 0. Okay, we are going to see what are all of these now. So, for example, if you are given the matrices like this, A, matrix A, you can see matrix A is this, matrix B is this, matrix C is this, and matrix O is this. Okay, so how are we going to know all of this? Actually, I have to perform the calculation for you, but I don't want to, I'm going to make it fast. For example, I'm just going to refer to one of the elements here. For example, A plus B, meaning that matrix A plus B. So the element here, element at row 1, column 1, plus with the element of row 1, column 1 of matrix B. Therefore, 2 plus -4, meaning that 2 minus 4 is a -2. B plus A, so it will be -4 plus 2. The answer will be the same. That is what we need to find out. And then when it comes to A minus B, I just look for one of the element here. A minus B means 2 minus -4 becomes 2 plus 4, right? Is equal to 6. When it is B minus A, -4 minus 2 becomes -6, and so on. Okay, so we look at the conclusion down here. Before that, you just observe carefully first. These remain the same. This is different because 6 becomes -6. Okay, this one you can do it on your own. Okay, I'll let you see the conclusion down here. The result of mind mobilization show that A plus B equal to B plus A. So addition of matrices obeys the commutative law. But then A minus B is not equal to B minus A. The 6 is not equal to -6 just now, right? So the subtraction of matrices does not obey the commutative law. Only the addition obey the commutative law. And then for the second one, the distributive law, both HA plus B, HA minus B, both obey the distributive law, meaning all the answer that you get over here are the same. Okay, this part, everything are the same. So both addition and subtraction of the distributive, they obey the distributive law. Okay, and then the third one right now, C. This is C. A plus B plus C, A plus B in bracket, is equal to A plus B plus C in bracket. So when it comes to addition over here, addition of matrices obey the associative law. But then when it comes to subtraction, you can see subtraction means that A minus B come first, then you minus C. They will not be equal to, you minus B with C first, okay, minus C from B, and then you minus A with them. So it does not obey the associative law. You just need to remember the subtraction usually does not obey, but the distributive law, yes, for both. Okay, and the last one. A matrix with all its elements equal to 0 is called zero matrix, for example, 0, 0, or the 0 here. Addition and subtraction of matrix A with 0 matrix or are A plus or equal to A, or A plus 0 equal to A, sorry. Then A minus 0 is equal to A. Nothing wrong, right? For example, if I have 2 plus 0, it's still equal to 2. 2 minus 0, the answer is still equal to 2 itself. So when it comes to 0 matrix, okay, you remember the subtraction and addition will remain to the original matrix itself, original number itself. Okay, so they show you the example of 0 matrix here on the right. The matrix of 0 with 1 by 2, the order, it will be 1 row, 2 columns. So 1 row, 2 columns. And then matrix 2 by 3, so 2 row, 3 columns. That is the example of 0 matrix. Okay, remember this is called 0 matrix. So I continue. Now we are going to look at the example. Okay, example 12 here. Given that P, you are given the matrix P and Q, calculate 3P minus Q. So 3P minus Q, the 3 remain the same. You are going to substitute the P with the P given, the Q with the Q given. So it becomes like this. So we are going to subtract it. We here, solve the one in the bracket first. So 7 minus 2, we get 5. 9 minus negative 3 means 9 plus 3 is a 12. Negative 3 minus 1, negative 4. 8 minus 5, 3. 6 minus 0 is still 6. 12 minus 4 is 8. Okay, after that you are going to multiply each of the element with the number 3. So 3 times 5, 15. 3 times 12, 36. 3 times negative 4, negative 12. 3 times 3, 9. 3 times 6, 18. 3 times 8, 24. So that's the answer. Okay, then we continue with example 13. So this is example 13. Okay, if you look at example 13 here, you're given that 1 over 2 times the matrix given minus x negative 3 equal to 5y. So calculate the value of x and y. Okay, so we are going to solve the first one here. So multiply each of it and then equal to 5 over y. So multiplication comes first. 1 over 2 times 4, we get 2. 1 over 2 times 12, we get 6. Okay, and then you combine them together to make it becomes equal matrices again. So 2 minus x equal to this. 6 minus negative 3 equal to this. Equal to 5y. Okay, and then you compare the corresponding element. 2 minus x equal to 5, solve it, so x equal to negative 3. This is 6 plus 3 equal to y, so y equal to 9. Simple. Okay, and then when it comes to B, question B here, you're given that 4R plus the matrix, and then is equal to negative 3, 4, 10, 1. Calculate matrix R only, this one only. So later on, you have to divide it by the number 4. Okay, go back here. Right, later on you have to divide by 4. So we see how does it go. Okay, you copy down everything. So 4R is equal to this minus this. Okay, because it's positive, when you send it to the back, it becomes minus. Okay, minus each of it. Negative 3 minus 9, you get negative 12. 4 minus 0, 7. 10 minus 2, 8. 1 minus negative 3, 4. After that, because you need to send the 4 to the back, it becomes divide by 4, right? Divide by 4 is the same as multiply by 1 over 4. It also means divide by 4 like this. So it becomes 1 over 4 times your answer that you have. 1 over 4 times 12, you get negative 3. 1 over 4 times 4, 1. 1 over 4 times 8, 2. 1 over 4 times 4, 1. Okay? Any question? Are you okay, class?
Yes, okay.
Yes, huh?
Clear.
I talk very fast because today I need to cover two parts with you. One is multiply a matrix by a number, and then the other one is multiply two matrices. So this part I consider is easy. Therefore, I just go through very fast with you. Okay, now we look at example 14 here. The average number of vehicles per day in a parking area for 5 working days is represented in table X. So this is table X. Okay, you got to see the question clearly over here. Huh? The average number of vehicles per day, meaning that this is the parking of the vehicle for 1 day only. Okay, and then table Y, this is table Y, will represent the average number of vehicles per day on weekends. Weekend, we have how many days in weekend? How many days of weekend?
2, right?
2.
Yeah, 2 days, correct. Okay, this part, I think down here I cannot continue because the conversion, it becomes very messy. So I'm going to move to the next slide here. This part. Sometimes, this one, okay, this one. Okay, again, just now this one, table X represent the parking, the average number of vehicle parking per day, for 5 working days, and then this one to represent the weekend. So they ask you to calculate the number of vehicles parked in the parking area in a week. In a week, we have 7 days. So this one is on weekday, meaning that we have 5 weekdays. And then this one is on weekend, so we have 2 days of weekend. Okay, so we are going to continue by using the matrix to do the calculation. So you can see over here, 5x plus 2y. This x plus 2y. Okay, all of the value in the table is converted into matrix 42, 8, 20, 11. And then all the value in this table is converted into another matrix 25, 5, 12, 3. So 5 times this plus 2 times another matrix. Okay, so you just need to do the calculation. 5 times 42, you get 210, 5 times 8, 40, and so on. 2 times 25, 50, 2 times 5, 10. So you add the element now, the corresponding element, 210 plus 50 is 260. 40 plus 10, you get 50. 100 plus 24, you get 124. And 55 plus 6, you get 61. So that's all for the answer of the calculation of the number of vehicles parked in the parking area in a week. So in a week, we have the number of, you can refer to the table here, meaning that in a week, if they ask you how many cars were parked in a week, so the number of cars that is parked in the covered area, there are 260. The number of cars that is parked in the non-covered area is 20. The number of cars, not cars now, is motorcycle. The number of motorcycle that is parked in the covered area is 50. The number of motorcycles that is parked at the non-covered area is 61 for that whole week. Okay, simple, right? So we continue. Now, this is the exercise that I want you to do. Can you mark it down, everybody? Take out your pencil. Take out your pencil. The question that I want you to do for exercise 2.2b is question number 1. You do all of it. Then followed by question number 3, 4, and 5. The rest no need because later on I have another exercise for you in the multiplication of two matrices part. Okay, so far, any question, class?
No
No
question.
questions.
Okay, so we proceed to multiplication of two matrices. Let's see whether I have a good one here. Okay, how to multiply two matrices. The normal multiplication, you can go through with this lah, but I don't want to explain this one in detail because I think you can understand this one easily. The one that I want to explain is this part. Okay, straight away, to multiply two matrices, for example, if I have 2, 1, 1, 2, 3, 5, 2, 6, for example, like this. You got to make sure the matrix has an order that can be multiplied. For example, the order for this matrix over here, the first one, this one, is matrix 2 by 2. This matrix is also matrix 2 by 2. So you got to make sure the number in the middle must be the same. Only then the matrix can be multiplied. If the number is different, for example, I have 2, 1, and then this is 2 by 1, 3. So I have 2, 5, 6. 2, 1, 0. Okay. If this is matrix, you can see this is matrix 2 by 1. This is matrix 2 by 3, right? When you found that the number in the middle is not the same, so you cannot multiply these two matrices. Okay. Now we go back to this. Okay, these two can be multiplied, right? But then what will be the answer? The answer is the number at the back. Okay, whereby you will also get a matrix of order 2 by 2. Okay, so that is what it means over here in the yellow box. If matrix A has an order of m times n and matrix B has an order of n times p, then the multiplication of AB can be performed and the order of AB is MP. The order is the one at the back, MP, like the one that I showed you just now, 2 by 2. Okay, so we will look into what are all this about by using the example given. Okay, you are given matrix C is at 3. So we set down first. This is at matrix 2 by 1. And matrix D, this is matrix 2 by 2. Determine whether multiplication of CD and DC can be performed. So if CD meaning that this multiply by this. So it will be 2 by 1 multiplied by 2 by 2. So they write it in this way. Okay. When you see the 1 and 2, they are not the same. Therefore, the multiplication of CD cannot be performed because the number of columns in matrix C, the column here, because the 1 represent the column, you can see this represent the column, and then compare is not the same with the number of rows in matrix D. The number of rows is different because it's 1 column, 2 rows. When they are not the same, so the multiplication of matrix cannot be performed. Okay, but then when it comes to the second one, they ask about the multiplication of DC. So D is 2 times 2, C is 2 times 1. So you can see here, 2 times 2, 2 times 1. The middle one is the same, right? Therefore, multiplication of DC can be performed because the number of columns in matrix D is the same with the number of rows in matrix C. Okay, and then the order of the matrix is matrix 2 by 1. You look at the one that is outside. Any question, class? Are you okay?
No
Yes.
questions.
Yes, okay, we have 31 students now. Okay, let me continue. Here. Have you all go and read through this part? Do you all understand what is this? Anybody have read through that part earlier? Nana, okay, none. I'm going to explain it carefully with this one, but I'm not going to use this example because it looks complicated. I don't want to make it complicated for you all. So let me see. 2, -3. Okay, I'm going to use this part. A 2, 3, 1, 5 and B -7, -2, 1. So I move to my whiteboard. Example 16. Let me show it to you. Example 16. Because I cannot write over there. Okay, example 16 here. I'm going to show it on the right. I'm going to copy this down. Okay. A equal to 2, 3, 1, 5. And then B is equal to 6, negative 7, negative 2, 1. When they ask you to calculate AB, so I move here. AB is the multiplication of the matrix 2, 3, 1, 5 with 6, negative 7, negative 2, 1. How do we multiply the matrix? It's very simple. You are going to multiply the row with the column. So the row with the column first. It falls on the first element, this part. Okay, how to get that? So it will be 2 times 6 plus 3 times negative 2. This multiplied by the first element, this multiplied with the second one. Okay, and then when you move it to the back, this multiply with, this remain the same, 6, negative 2. So this multiply with this now, it will move to the second element here. So it will be 2 times negative 7 plus 3 times 1. Okay, now we have done both the element because we know that this is matrix 2 by 2. This is also matrix 2 by 2. Therefore, the result that came out will be 2 by 2, matrix 2 by 2. Okay, which means you will have 4 elements, a square matrix. Now we move to the second row. Second row multiplied by the first column, so it is 1 times 6 plus 5 times negative 2. Okay, and then we move to the second row with the second column. So 1 times negative 7, better write down in bracket lah, so it looks tidier. 1 times negative 7 plus 5 times 1. Close your bracket. Okay, hopefully you understand. So then we can get the answer already. 2 times 6, 12. 12 minus 6 is a 6. 2 times negative 7 is negative 14. Negative 14 plus 3 is negative 11. And then 1 times 6 is 6. 6 minus 10 is negative 4. 1 times negative 7 is negative 7 plus 5 is negative 2. So that is how the multiplication of matrices is done. Do you have any question?
No question.
No question? Okay, we move to another one, which is example 17. Example 17, I have to show you slowly lah, because there are different matrices that came out from the calculation given here. So let us look at example 17. It is given that matrix E, a matrix of 2 by 3. Okay, this is 2 times 3. And then matrix F, this is matrix 2 by 1. Matrix G, 4, 3 is matrix 1 by 2. They ask you to calculate GE. Okay, so we are going to refer to G, this one, and also E. Okay, let's do it. GE is equal to 4, 3, multiplied by 5, negative 1, 0. This is negative 4, 8, 7. Okay, if you look at matrix GE again, this is matrix 1 by 2. And then the other one is matrix 2 by 3. So we know that the matrix can be multiplied because the the column for the first matrix and the row for the second matrix is the same. They are the same. So came out, the result later on will be matrix 1 by 3. Okay, I change this to a thicker one. Okay, 1 by 3. So you will have matrix 1 by 3, yeah? Okay, now we continue the calculation. Okay, so this will be 4 times 5 plus 3 times negative 4. Okay, like this, this times this. So we will have a matrix 1 by 3, which means it is like this, one row with 3 elements. So the first answer will be 4 times 5 plus 3 times -4. Okay, and then the second one is the row multiplied by the second column. So it will be 4 times -1 plus 3 times 8. And then the third one is the first row for the first matrix multiplied by the third column. So it will be 4 times 0 plus 3 times 7. Okay, then you can get the answer already. 4 times 5, 20. 20 minus 3 times 4 is 12. 20 minus 12 is 8. Okay, followed by 4 times -1 is -4. -4 plus 24 is 20. And then the last one, 4 times 0, 0 plus 3 times 7, 21. So that is how we get the answer. Okay, so matrix GE is equal to 8, 20, 21. Any question, class?
No question.
No
No
question.
question, huh? Okay, so we continue. Then we are going to look for FG. So I think I wrap this off. Okay, we look at FG. FG. So I'm going to write down for question B, FG is equal to -2, 7 multiplied by G is 4, 3. Okay, so I show you the order of matrix F. You know how to get the order of matrix F or not? Somebody tell me what is the order of matrix F? Who is this? Shami, are you there? Shami? Shami,
Yes,
are you there?
madam.
Okay, good. Shami, can you tell me what is the order for matrix F? This one?
1 times 2. 1 by 2.
1 times 2. How many rows? Row come first.
2 times 1. 2 by
Yes,
1.
we do 2 by 1. Thank you, Shami. And matrix G, somebody else. Because just now I already tell you what is the order of matrix G. So now I'm going to ask you. Zawani, are you there, Zawani? I just picked randomly. Zawani, what is the order of matrix G? This one. You cannot. Let me see.
1 by 2.
Yes, who answered me that? Gary, is it?
Yes.
Thank you, Gary. Okay, so it is matrix 1 by 2. Very good. Another question. Can these two matrices be multiplied? Matthew? Can these two matrices be multiplied? Hello, Matthew. Matthew, are you there?
Yes, madam.
So, can it be multiplied? Matthew?
Repeat again, madam.
My question is, can these two matrices be multiplied? -2, 7 and 4, 3. Can it be multiplied by looking at the number in the middle here? As long as the number is the same, the matrix can
be
Yes.
multiplied.
can be multiplied. Okay, Matthew, another question for you. Do you know what is the outcome of this matrix? What is the order of the matrix that I have later on?
2 by 2.
Very good. It is matrix 2 by 2. Thank you, Matthew. So we will have matrix 2 by 2 later on. To determine whether it can be multiplied or not, the number in the middle here must be the same. Okay, so we are going to continue with our calculation here. You be alert. Later on, I still have question for you all. Okay, so later on, we are going to have a matrix 2 by 2. So calculate this one here, which will be first Sorry, I circled the wrong thing. It's supposed to be negative 2, 7. Because usually we calculate the row multiplied by the column, right? So it will be negative 2 multiplied by 4 only to get the first element here. Okay, because we have matrix 2 by 2. Okay, we are going to get this one. Therefore, this is negative 2 times 4. First row multiplied by first column. Okay, now we only have one row. First row multiplied by second column here, we will get this element on the right. So it is negative 2 times 3. And then second row with the first column, 7 times 4. Second row with the second column, 7 times 3. Okay, then we can calculate the answer already. Negative 2 times 4 is negative 8. Negative 2 times 3 is negative 6. 7, 4, 28. 7, 3, 21. Okay, that is matrix FG. Okay, which came out matrix 2 by 2. But you don't have to show the border over here. I just let you see only. Okay, now we proceed to the C. This one you understand, class? You have any question or not?
No.
No question, I continue with C. Yeah? Okay, so C is matrix GF. So let's see matrix GF. GF is equal to, get ready to answer the question. G is 4, 3. F is negative 2, 7. Okay, so this is matrix 1 by 2. Now, question for the next person here. Daniel Izadin, are you there?
Yes, madam.
Okay, Daniel, can you tell me what is the order for this matrix? Matrix F.
2 by 1.
2 by 1. Thank you, Daniel. Very good. Okay, next question. Who are here? Putri, are you there, Putri? Hello, Putri. Hello, Putri, are you there? Putri, are you there? Nobody answer me. Putri, for the third time, are you there? You go to the toilet now. Okay, Adelina. Adelina. Okay, Putri. Putri back already, Adelina. Sorry, I go back to Putri first. Putri, can you answer me? Adelina, you hold on. Later on, I come back to you. Okay, Putri, question for you. Can these two matrices be multiplied? Can you answer me with your voice? Or your internet's slow? Okay, never mind. Then Adelina, can these two matrices be multiplied? Can you turn on your mic? Can. Okay, thank you, Adelina. Yes, it can be multiplied because the number is the same. Now, another question. What is the outcome of the multiplication of these two matrices? Hedy, what is the outcome?
1 by 1.
Yes, very good. The outcome will be matrix 1 by 1. Okay, so you understand already, yeah? Matrix 1 by 1 meaning that you only have one element in here. Okay, so let's see the calculation. Remember, it is row multiplied by column. So we only have one row, one column. Straight away, the matrix will be 4 times negative 2 plus 3 times 7. So 4 times negative 2 is negative 8. 3 times 7 is 21. Okay, negative 8 plus 21. The answer is 13 only. So this is matrix 1 by 1. Are you okay, class?
Yes.
Okay.
Okay, madam.
Okay, good. Then I continue with the next question, which is example 18. Okay. Example 18. Okay, it's here. So as long as you know how to do example 17, the rest won't be a problem for you. Now we look at example 18. It is given that matrix K, you are given matrix K, which is matrix 3 by 2, and matrix L is matrix 2 by 2. Calculate L squared. So L squared, you have to write the matrix twice, which is negative 4, 2, 0, 1, and another time. Okay, so when you multiply, you are going to multiply the row with the column. First row, first column. So they make it fast now. You can see -4 times -4, 16. 2 times 0, 0. So 16 plus 0, you write straight away. Okay, now I move to the second element. Second element meaning that it is the first row multiplied by the second column. So -4 times 2, -8. 2 times 1, 2. Okay, now I move to the second row with the first column. 0 times -4, 0. 1 times 0, 0. And then for second row with the second column, 0 times 2, 0. 1 times 1, 1. And then from here, we solve it. 16 plus 0, 16. -8 plus 2, -6. 0 plus 0, 0. 0 plus 1, 1. Okay, that is how you get your answer. Okay, bear in mind, your L squared, it cannot be like this. -4, 2, 0, 1. It cannot be like this. Okay? Or it cannot be you cannot write it as negative. No, that's all. I don't want to confuse you. Okay, now you look at KL squared. So you already have the L squared. This one. You are going to copy down the matrix and multiply with matrix K. So this is matrix K. You can see KL squared matrix K multiplied by L squared. Your L squared is what you have got just now. This one. So you multiply it. Okay. Again, you got to do it slowly, one by one. First, you need to check. This is matrix 3 by 2. And then this is matrix 2 by 2. So later on, you are going to get matrix 3 by 2. So you can see 3 rows, 2 columns. Okay? So that's correct already. Now we are going to check. This one, remember, it is row multiplied by column. 3 times 16 is 48, plus 2 times 0, 0. Each of it, 3 times -6 is -18. 2 times 1, 2. Now move to the second row. -1 times 16, -16. 5 times 0, 0. Okay. Second row with the second column now. -1 times -6, +6. 5 times 1, 5. And the rest, so after that, you just need to solve it, you get the answer. Solve it, you get the answer. And so on until you get this. Okay? And then for the third one, L cubed. So L cubed is L squared plus L because you already have your L squared earlier. So just copy down and multiply by the original L. Your original L is -4, 2, 0, 1. So you just copy down -4, 2, 0, 1. Okay, and then you can see the order of the matrix is 2 by 2 times 2 by 2. So you are going to get matrix 2 by 2. So same thing, the first row multiplied by the first column. 16 times -4, we get -64. Plus -6 times 0, we get 0. So this one represented by this. And you solve, and you will get all of this. Okay, I move faster. Okay, example 19 now. This one, again, they want you to find the one of the element inside. So they give you x and y, ask you to calculate the value of x and y. So what you need to do is you have to get equal matrices first, like this. Okay, so 6x times 2, this one, plus -5 times 3. Okay, 6x times 2 plus -5 times, first row with first column. Sometimes I also confuse. 6x times 2 plus -5 times 1. And then 6x times 3 plus -5 times 4, this one. So you show everything. After that, actually you don't have to show like this. You just need to show this one. The whole thing is equal to 7, 1 minus y. Okay, which means this part here is equal to 12x minus 5. So 12x minus 5 is equal to 7. Okay? And then you get the answer of x. Whereby the other one, when you get the second element is 18x minus 20. 18x minus 20 is equal to 1 minus y. So you compare the corresponding element, 18x minus 20 equal to 1 minus y. Solve it, you get y equal to 3. Okay, I move to, I think this is supposed to be the last example. Let me see. Yes, this is the last example here. Pay more attention. This one is easy. I think at the end of each of the calculation, you will have a problem solving like this with a table. So the table shows the share units purchased by Carriel and Mahmoud. Come back to share again. So for share A, Carriel purchased 5,000, Mahmoud purchased 2,000. Whereas for share B, Carriel purchased 4,000 and Mahmoud purchased 6,000. It is given that the price of 1 unit of share A and 1 unit of share B during the purchase are 150 and 0.82. So the price will be something like this, 150 and 0.82 cents. Calculate the total investment of Carriel and the total investment of Mahmoud. So if you want to calculate the total investment, you have to multiply the unit with the price of the share, which means this one, 5,000, you got to multiply with the price of the share. So you write down here, copy down all of this in the form of matrix, which is 5,000, 4,000, 2,000, 6,000. And then you are going to multiply by the price of the matrix. For share A is 150, for share B is 82 cents. Okay, after that, you check, this is the order of the first matrix is matrix 2 by 2. The order of the second matrix is matrix 2 by 1. So your outcome will be matrix 2 by 1. Matrix 2 by 1 meaning that you have 2 rows, 1 column. Okay, so first row multiplied with the column. 5,000 times 150 is 7,500. 4,000 times 82 cents is 3,280. So you have this. After that, the second row multiplied by the column. 2,000 times 150, you get 3,000. 6,000 times 82 cents, you get 4,920. So when you add them up, this is the price of the Carriel and Mahmoud. Okay, so the answer given, the total investment of Carriel and Mahmoud are RM 10,720, 80, and RM 7,920 respectively. Okay, so do you have any question? No question. Any question?
No.
No.
No question,
Understand.
Oh, good. Okay. Then I just want you to do the exercise here. The first one I've given to you. For those who miss out the lesson later on, maybe when I pause the video, you check. So self-practice 2.2C. I want you to do question number 2, question number 3, and question number 5. Okay, it will be a lot. So for question number 2, you don't have to do all. I choose some for you. A, D, E, F. Because you have a lot of exercise today. Okay, so now we are going to try to do this together. We are going to try to do question number 1 together. Let me open it up bigger for you. Everybody, pay attention. Given that 4 matrices, you're given matrix P, matrix Q, matrix R, and S. Determine whether the following multiplication of matrices can be performed. If yes, set the order of the product of the pair of matrices. Okay, meaning the outcome lah. So, matrix PQ. Okay, before I ask you the question here, Let me go through the order of the matrix one by one. Okay, matrix P. Can somebody tell me what is the order of matrix P? Faiz. Yes, Faiz. Are you there?
It is 2 by 2.
Yes, thank you. So I write it down first. This is matrix 2 by 2. Okay, matrix Q. Aiman, matrix Q. Aiman, what is the order of matrix Q? Aiman, are you there? Aiman? Knock, knock. Anybody home? Aiman, are you home? I see your picture, very nice there. Are you home? Aiman? Aiman once, Aiman twice.
Tengah belayar, madam.
Probably a toilet, madam.
He eat a lot. Okay, I change. Who is this? Ahmad Ashad. Ahmad Ashad. What is the order for matrix Q? Ashad, are you there? Okay, what is the order of matrix Q, Ashad? Can you turn on your mic or you can only write? Okay, what question? The question is, what is the order for matrix Q? This one. You have to write, is it? One by one. Is it one by one? Are you sure? It's not one by one, no? Give me another answer. It's not one by one. Two by one? Yes, thank you. It is two by one. Okay. Next. What is the order of matrix R? Be ready, everybody. Who are here? Afifa. Afifa, what is the order of this matrix R?
1 by 3.
1 by 3, huh?
Yes.
Okay, thank you.
Madam.
Very good. Yes? Yes?
Madam.
Yeah?
Yang 7-2 tadi tu, madam.
Apa, Gary?
Cuba tengok question tu tadi, madam.
Aha.
Yang 7-9 tu bukan 2 by 1 lah, madam.
Ya, cikgu salah tulis. Thank you, Gary. Cikgu salah tulis. Okay. Last one, S. Okay, Gary, you answer me. What is the matrix order for S?
Two by 3 kan?
Yes, very good. Thank you, Gary. Okay, we have the order of the matrix already. Now we are going to find out whether each of these matrices can be multiplied or not. P and Q. So you observe P and Q. P and Q. Everyone, you observe P and Q because I've given you the order already. Okay. If yes, then you got to tell me what is the product or the outcome. Imran. Imran. Your turn now, Imran.
Yes, madam.
Okay, Imran. Can A matrix P by Q be multiplied or not?
Yes.
What is the outcome or the product of the matrix?
Okay, product. Wait, madam. Take the textbook.
Again?
Sedih, man.
Yeah, Imran, what is the product of matrix PQ? The order of it.
Yeah. What is the question again, madam?
Okay, the question, I repeat, you said matrix P and Q can be multiplied just now, right?
Yes.
So what is the order of the product of that two matrices? Yeah.
2 by 2.
2 by 2. Are you sure?
Not very sure.
Not very sure. If you want to get the product of that two matrices, you refer to these two. So the product is, what is it, Imran? What is the product? I give you the answer already. Is it 2 by?
2 by 1.
Yes, thank you, Imran. Okay, next person. You look at B now. Q, R. So you observe Q and R now. Okay, Q is matrix 2 by 1. This one, 2 by 1. And then R is matrix 1 by 3. Okay, next person. Januel. You guys talk a lot in here. Januel, are you there? Hello, Januel. Okay, Januel.
Yes, madam.
Yes, tell me QR can be multiplied or not?
Yes.
Yes, good. What is the product of that QR?
2 by 3.
Yes, very good, Januel. Thank you. Next one, C, RS. Now we look at RS. So it is matrix 1 by 3 with matrix 2 by 3. Okay, RS over here. Who's the next one? Elika. Yes, Elika. Are you there?
Yes, madam.
Okay, Elika. Can C, this RS be multiplied or not?
Cannot,
Cannot. Why?
because the middle number is not the same.
Yeah, because the column and the row is not the same. Thank you, Elika. Okay, next one, we look at SP. So make sure you look at S and P. This is S, 2 by 3, and P is 2 by 2. Okay, so I rub this off. Okay, who is the lucky one right now? Waida, are you there, Waida? Waida? Hello? Hi. Sorry, I pressed the wrong thing just now.
Oh, okay. It's fine.
It's okay, madam.
Okay, madam. It's fine, madam.
Luckily, you're all still there. Next time you work for me, you don't go away. I'll come back to you. Okay,
General
Waida.
teaching just now, madam.
Huh?
General teaching just now.
Is it? Wow. So, Jenwell, can you continue the presentation? Okay, just now I was calling for Waida, right? Waida? Are you there, Waida? Waida? Okay, Waida, come back to this question again. Question D here, S times P. Okay, S times P. Can it be multiplied, Waida? Yes, okay. What is the product of S times P, Waida? What do you mean yes or no? Meanings that cannot be multiplied, is it? Now you look at S times P again. S times P. So S is 2 by 3. P is 2 by 2. Okay, thank you. The middle number is different, right? So we cannot multiply these two. Okay, thank you, Waida. Now we move to the next one. P times S. So P is 2 by 2. S is 2 by 3. Can it be multiplied? Okay. Now, I can't see your name here. I have to press it once. Amel. Hi, Amel.
Yes, madam.
Okay, Amel, can it be multiplied for E?
Can, madam.
Can. Okay, what is the product of that two matrices?
2 by 3.
Thank you, very good. Okay, next one, QP. So you can see Q is 2 by 1. P is 2 by 2. Can it be multiplied? This is the last one. Who is here? Eclair. Long time no see, Eclair.
Yes, madam.
Okay, Eclair. Let me know whether it can be multiplied or not.
Cannot.
Cannot, yeah, because this is 1 and 2, right? Thank you. Okay, so class, you all understand how to determine whether the two pair of matrices can be multiplied or not?
Yes.
Understand.
Okay,
Understand.
so
Easy.
everybody jot down the exercise for today already?
Already, madam.
Already, okay. Reminder for those who entered late just now. I want you to take the attendance right away because I make a due date for that one. So make sure you take attendance for today here by 9:30, the latest. Okay, this one, 31 of you already took your attendance. So I have 34 here. 3 of you haven't do so. Okay, make sure you go and do it later on. And for the exercise that we have discussed today, which is the matrix homework 2.2a just now. Okay, 4% already turned in. The rest, please do so. And also the previous one, you see there are still 22 haven't turned in. So I'll let you see again for those who haven't turned in. These are your name. Please do so as soon as possible. Okay, Marcellus, again, you have to press the submit button. Okay, you see your name.
I haven't do the 2B yet, madam. So that's why I haven't submit.
I mean this one, the one that you have submitted. But then, yeah, because you haven't pressed the submit button, that's why you are under this category. You are under the assigned category. If you have pressed that button, then you will be under the turn in category. Like them.
I haven't.
You haven't pressed button only. Later on you go back.
Do do one question, madam. So that's why I
Is it?
haven't.
Okay. So make sure you finish.
Put it in. All
Make
right.
sure you finish it. Okay. So
Okay.
ask you, class. You don't have any more question, right?
No.
Yes.
Okay. Then see you on next Wednesday. Okay.
Alright.
Okay.
Thank you, madam.
Thank you, madam.
You're welcome.
Thank you, madam.
Bye, madam.
Thank you, madam.
Okay.
Thank you,
Bye.
madam.
Thank you, madam.
Bye.